Tonight, kind of, I think, interesting topics, especially HSRP, Hot Standby Routing Protocol, which is to configure a backup router. And then we'll talk a little bit about cloud services overview, access control lists again, and then troubleshoot access control lists, and then configure VRRP. The two redundancy protocols are at each end of the lesson. HSRP is a Cisco proprietary, VRRP is the standard. They both do the same thing, which is to provide a backup router in case one goes down. I was thinking today, it's kind of like the backup quarterbacks in the NFL. You've got your obviously your primary, the one that is the most capable probably, and then a backup, so that if the primary goes down, you can use the backup for as long as you need it. But what we do here is to create a virtual, lost my pen, a virtual router here, 192.168.0.2. And the active routers, I'm going to show you a configuration. I'm not going to make you suffer through watching me do it. The physical interfaces on the routers have IP addresses. The virtual router is going to be the default gateway, so it will be the gateway address here. It gets a MAC address, and the MAC address is predefined. We'll look at one here in a little bit, when we look at the configuration. But it gets a MAC address. We can dictate based on the priority which one of these is the active router and which one is the standby router. When we talk about priorities, the default is going to be 100. They do the negotiation. The one with the highest priority is the one that's going to win. When if this active router goes off, the standby router automatically assumes the responsibility, and this IP address shifts from over here to over here, so that the traffic, we don't really lose anything. The traffic continues to flow. What's the downside? We got one router just kind of hanging around, not doing a whole lot of anything. One of the ways to make that more efficient is to have two virtual routers, two groups. Standby is the command that we use to create these things. Two standby groups, one of them maybe with an IP address of 0.2.2 and maybe with a address of 190.0.2.254 perhaps. And we set up DHCP so that maybe it gives like half of these guys the 2 address for the default gateway and half of them the 254. That way we can configure the active router here. Let me see if I can erase that part. The active router, so that it's not quit. The active router will be active for the .2 network, and then the standby router can now become the active router for the 254 bunch, so that we're actually using both of the routers, and I'll show you a configuration on that here in a minute. But virtual router, one goes down, we continue to have our traffic flow. This is kind of the same picture, I guess. Virtual router, standby router, active router, different IP addresses. They use the .2. They use they just went across 1, 2, 3. What I would do, and what I guess would be convention, is we'd make this one the 2 and we'd make the default gateway the 1. That's just kind of convention how we do it, 1 or 254. It doesn't matter as long as we don't assign that IP address. HSRP, Hot Standby Routing Protocol, first hop redundancy protocol, FHRP, to provide a transparent failover of the first hop IP device or the default route. Okay, that means just exactly what I said. The router that we're using goes down, then the backup router, the standby router, is going to come up. At HSRP Cisco proprietary, provides multiple routes to any router, including the default route. High network availability by allowing the first hop routing redundancy. IP host on the network's configured with the default gateway IP address, and the default gateway is going to be to the virtual interface. Used in a group of 2 routers. Now, I think that the assessment says unlimited, and I have done this with GNS. Packet Tracer won't let me add a 3rd router. If I add a 3rd router, the other one is just kind of there. It's available. It's configured, and I don't remember exactly what it calls itself, but we can have 2 routers, with one router being the active device and the other router being the standby device. So in reality, that's what we are. Again, the end of course assessment, I think that they've got a different kind of answer. We'll hopefully look at that. I want to look at the questions that I was going to do last time. HSRP, when we use it, the HSRP virtual address will be configured as the host's default gateway. Different from the usual practice where most IP hosts will have an IP address of a single device, such as a router configured for a default gateway. And yeah, we do that. And I'm doing the slides based and what we've done earlier. This, I think, is the same thing that we said earlier. When we configure it, it'll provide a virtual MAC address and an IP address share among the devices that are running HSRP. And the MAC address, the advantage here, once we get the MAC address, it doesn't change. Remember, the MAC address gets cached on the devices, and we have to use the ARP protocol to find the new MAC address. But if it doesn't change, then we don't have to worry about ARP. The cached ARP address is still valid. So the advantage there, the virtual MAC goes with the virtual IP. Will be useful that do not support the discovery protocol such as IMP, route discovery, IRDP, which no Windows devices do, and that's what most, not all, but most companies are still using. Cannot switch to the new device when their selected device is reloaded or loses power. Can be used because of the existing TCP sessions can survive the failover. Provides a more transparent recovery for the host, and it detects the designated active device has failed at the same time a selected standby will assume control of the MAC and IP of the HSRP group. A new standby device may be selected at that time if there is another device running, the one that's just sitting there idling, waiting to be picked to do something. Uses a priority, I guess it'd be like the 3rd string quarterback, to determine, uses a priority mechanism to determine the configured device. The priority, the default is 100. We can configure those. Typically, we would give a priority. The one we want to be the active, we can make it a priority of maybe 120, 105, 101 would work when we do that, as long as it is a higher priority. These things won't automatically resume, and I guess I should wait to the slide, but I like to do the things when I think about it. Let's say that this happens, that the active device goes down and the default device takes over, or the standby device takes over. The 120 goes down. The 100, let's just say we didn't change anything on it, the standby takes over. The 120 goes down. The 100 now becomes the active device. We fix this guy, it comes back up. Unless we have configured the preempt command, it won't take over the active role again, even though it has a higher priority. When they start up, it will, but unless we configure it as preempt, it won't do that. It won't reassume the role. Priority, when, yeah, here we go. See, I figured it was when preemption assign a priority to the routers will allow you to select the active and standby. When preemption is enabled, the router with the highest priority will become the active router. If the standby router is the active router, it'll take over. And this is called a coup, and it actually sends a coup message. If the priorities are equal, the current active router will not be changed, and the highest priority, 1 to 255, will represent those. When you set a priority, preempt or both, you need to specify at least one keyword, priority, preempt, or we can do both, and we will have done both on those, on the ones that we're going to look at. When you configure the interface with a standby track command and another interface on the router goes down, the priority of the device will be changed dynamically. Primary troubleshooting tool is show standby. So show standby is going to show us what's going on these things. Preempt feature enables the router with the highest priority among the remaining routers to immediately become the active router. So preempt becomes a significant issue here. If you have one, you set the priority 120 and it's active, it's active, it's active, it goes down. You fix whatever's wrong, it comes back up, and it's standby, it's standby, it's standby. Check to be sure that you have enabled preemption. Allow the standby device to delay becoming the active for a configurable amount of time. This is okay. It went down. Maybe just the interface got bounced, shut down, no shut. So before he actually goes through the coup process taking over, we can configure a delay. Will be determined first by the configured priority value and then the IP address. So here we go again. The IP address, highest IP address, is the one that will be used if we have not configured the priority. So if we leave them all at 100, the one that's going to be preference is going to be preferred will be based on the IP address. IP address, the higher value is treated as a greater priority. Higher priority router that preempts a lower priority router will send a coup message or a hello message to the latter. Lower priority receives the coup message, then it will change to the speak state and send a resign message. So we get a coup message and then we get a resign message. Versions, HSRP version 1 default has the following features, and here they are. The group number 0 to 255, multicast address 224.0.0.2. There's a problem with that because the multicast address 225.0.0.2 was also for the Cisco group management protocol. So, and both of them are Cisco's, and Cisco proprietary. It's like, okay, how did they do that? But they did that. HSRP v2 uses a different multicast address 224.0.0.1.0.2, different packet format, and it can have group numbers from 0 to 4095. The next thing on here is are the labs, but before we do that, I want to show you a couple of things here. This is a topology, and the little thing about track, let's say that this is for group 2, this is the active, and group 1 down here, this is the active. So group 1 is fat, dumb, and happy going this way. And all of a sudden this interface goes down. Well, the router didn't go down. The groups down here didn't go down. So we keep sending traffic here and it keeps going nowhere. And I'll be able to show you that here in a minute, because packet tracer doesn't quite do all of that stuff. What I've configured here is one of these groups is I've got 2 groups. One is group 1 is active and the other one here is going to be standby. So group 1 goes this direction and group 2 goes over here, so that we are actually using both of the routers. I didn't do that on the path back. This one is active, and this one is going to be standby. So what happens when we start these things up? And to make it a little easier to look at this stuff, I copied and pasted the startup with the states here. The group one went from init to init, initialize to initialize. All of them did that. Then the interfaces got up. So group 10 went from speak to standby. Group 10 state went from standby to active. So it went to standby. So okay, I should be the active now. Group 2 went from standby to active, and group 1 went from speak to standby, standby to active, and then speak. Group 10 went from speak to standby. So, and these are the different interfaces on these things, and the different ones that are available on it. The configuration itself, this is not a very complex thing to configure. The duplex auto, speed auto was already there. Standby version 2, so this is a version 2, we could do more. The way we set this thing up, and we have an interface gig 00, which is going to be the ones down here. Gig 00 has an IP address on it. If I can get this back. Has an IP address on it, 192.168.1.2 subnet mask. So we do standby 1, IP 192.168.1.1. Let's make that the default gateway. I want this interface to be the active interface for this group. So I give it a standby 1, priority 120. And if it goes down and comes back up, I want it to take over again. So I give it a standby 1 preempt. The other one, I want to kind of share this. So what I do is make another standby group, standby 10 with an IP address 192.168.1.10. Okay, so I didn't use the 254. I used the 1.10 for whatever reason when I was doing this. And then we get interface gigabit 01, which is the outside address, standby 2, 192.168.2.1. I gave it a standby of 109. The reason is when I go down here with the standby 2 track gigabit Ethernet 00, I'm supposed to be able to give it a preempt or a decrement command, which says that if this interface goes down, decrease or decrement the priority by this amount. Well, the decrement command doesn't work. The default decrement's 10. So I made it 109 so that it would decrement it under the priority of 100 when I did that. So gig 01, we're tracking it, or yeah, no, we're not. We're tracking gig 00 so that if it goes down, we're then going to decrement this one because we have a standby priority 109. It's going to be the primary. So when I look at this, we can go in here and show run, and those are the configurations that we have. And I'll cheat here, if I go into gig 00 and turn it off, then we should get some things that happen. Group 1 state went from active to init, and if I go to the other device, it's gone from standby to active. The problem with Packet Tracer here is that this didn't change. This interface didn't get shut down like it should have, or this group 2 active didn't get changed here. Group 1 active did. And if we show standby, which is our primary command, group 1 interface down here it says preemption is enabled, the active router is unknown, the standby router is unknown, priority 120 is configured, and here's the group name. What I wanted to show is the MAC address also. They may ask questions about this. So the MAC address 00000C and all of that says Cisco. And then 9F0. The last two digits here represent the standby group number. This one is group 1. If we go down here, A would be group 10, and here we are, standby group 10. The same prefix on these things, but the last two digits represent the group number that we have on it. So when I go up to the gig 01, it's still active, 8 state changes. Interestingly enough, and this is a kind of oh, this thing's been dying on me all day long, and I don't know why. Okay, so packet tracer's back. If I go in here, well, first of all, let's see if it works. This device up at the top, this server up at the top is 2.1. One of the things, let me try something else here. Let's go in here and let's don't, because it takes too much time to do this. So if I go in here, I'm wasting time, I know. Let's do a trace route. 192.168.2.1. Yeah, that's not where I wanted to go, was it? What is the IP address of this guy? 1.2 probably. 2.1. Anyhow, it goes to 1.2, where that is the wrong address, obviously. Yeah, 2.100. I knew it was the wrong one. Yeah, while this one is finishing, it's can't get there. Let's trace route 2.168.2.100. Its first stop is 1.3. The other one that couldn't actually get there, first stop was 1.2. So when we get here, and we'll come back to this one. Let's see if this guy is ready to quit, and he's not. Let me bring it over on this one and see if it'll control C over here. Still won't. Anyhow, he went to trace route. He went to tracing. It went to 1.2, which was one went one direction and the other one went in the other direction. What I'm going to do is go in here and turn this device off. If I can find the power switch. They hide them on me. And turn this device off. So what should happen now is it has just become, you can see it jumped up there, it's just become the active on this thing. So it has now become the active router. This one should still go to 1.3 because that was where it went before. And if this guy will ever time out, it'll go there also. Let's go ahead and keep going with this. The next topic is cloud computing, and this is conceptual. I will look at one of the providers. Let's go ahead and look at one of the providers right now. This is Rackspace. And the only reason I'm looking at it is because it used to be close, and they're going to call us, email us, sign up, or log in. Different solutions, what are they going to do? What they're going to do is host for you. We are used to installing one operating system on a single machine, and you've seen me use the VMware workstation, which I did get running again. They do this on a larger scale. I used to have a student who worked there. He said that they have like 63,000 physical servers, or they did at the time. But this is virtualization, not a real efficient form of virtualization. It runs on top of the operating system. The virtualizations that you run on a larger scale are like VMware ESXi or ESX, which is a software that's designed to virtualize. But I have a number of different possible systems here that could be running. Go to Ubuntu, a Windows 8, a Debian 7, and then a Windows Server, as well as some GNS3 machines that are available. I can run one. As long as I have enough resources, I can run one or all. What this does is shares the resources. I can assign a certain amount of memory. I can go in and configure it, how many processors it gets, how much hard disk space it gets. So we can apportion the resources and share the resources, and that's really what we do. And then they have services, managed hosting, managed cloud, co-location, lots of different things, the platforms that they have, and then the resources, resource center support, and about services, managed hosting. They had one in here a little while ago that I saw was dedicated servers, but we're not there. We've got dedicated servers. When you go in here, you can it's a truly single tenant, secure and backed by fanatical support. Benefits of these things, kind of a diagram of what you get, and then you can go in here, processors, memory, add 3 terabytes, how much do you want, service levels, managed, or whatever else. Virtualization, Rackspace virtualization on VMware or Microsoft Hyper-V, you can specify. So what we can do is go in and using a checklist, we can tell the system, tell them how much we want. Amazon Web Services, they look like, I was just looking at it, it looks like it has I didn't sign up for it, a free capability to learn about Amazon Web Services. So cloud computing, the Cisco definition is IT sources and services that are abstracted from an underlying infrastructure and provide on-demand and at scale with a multi-tenant environment. On demand, we can go to the website and say, hey, I need more CPU power, I need more storage, I need more whatever that we do need. And when we do that, on demand and at scale, how much and when do we need it, so that we can go in and configure it. And that's one of the things that it is required. Multi-tenant on these servers, we're going to get our little spot in the sun, our little access, our little resource sharing. There are going to be other users, just like I showed in the VMware workstation, that there are multiple machines. Those could be multiple tenants, multiple different companies that are there. Problem with that is, who's there? Is it a hacker next to you, somebody that's trying to put viruses out? There can be some issues with things like that, although security's gotten better and better with these things. provides a method for offering IT services, offers IT services, servers, databases, network, security, and all the related hardware and software. This has really kind of been an advantage for some small companies because they don't now have to have an IT department. They can go hire an IT department in the cloud and use it there. Virtualization products, virtual machines, products such as physical servers built specifically to enable cloud features. So the 63,000 we talked about, and then you saw that they had the VMware, and then they also had Microsoft if you preferred. You can run your own. You can run your own ESXi, buy the software from VMware. You can run a Microsoft Hyper-V. So the cloud clients, web browsers, mobile apps, thin client, terminal emulator, and you may or may not have ever seen a thin client. Well, thin client is basically a remote workstation. It's got a keyboard, a mouse, a monitor, and you can contact remotely. What you're really doing is running a remote desktop session so that you connect to a virtual machine. One of the advantages that we used for cloud computing, and it was a private cloud because it was within the building, is we have a bunch of old machines, and so instead of throwing them away, what we did, they sent us a bunch of servers, 2 servers that they wanted Active Directory on, and it was kind of a waste of resource. So we made virtual machines in here, and the old machines that were out in the offices, and some in offices, some in classrooms, then got a client on it, a remote desktop client, a Linux remote desktop client, a very small version of Linux. But what the running was happening was everything was happening on the server, so that these machines that could barely run XP were running Windows 8 and Windows 10 at the time. So we have different kinds of clients, thin client, terminal emulators, web browsers, different ways to connect to it. SAS, software as a service, CRM, email, virtual desktop, communication, games, things that we kind of use on a regular basis. Gmail, email. Gmail is in the cloud somewhere. Platform as a service, database, web server, development tools. I maintain a website or help maintain a website for a club, and we have a web server that's at 1&1. So it's a platform as a service. The platform is the web server. And then infrastructure, virtual machines. And if you go back and look at these providers, they'll go at basically as far, provide for you as much as you think that you need or you think that you want from them. So if I erase that, it'll work better, huh? So these are the things that it's got to be from the definition of the U.S. Institute for Standards, NIST, on-demand self-service, be able to choose when to start and stop using the service even without having a direct interaction with the provider. So it's saying that we can order it up and cancel it on the internet. Broad network access available for many types of devices, from our Windows machine, our Linux machine, our Android tablets, our iPads, and all of the different other capabilities that we might be able to think of. Resource pooling, create a pool of resources instead of dedicating the use of specific servers only to certain consumers. In addition, we'll provide dynamically allocate resources from a resource pool for each new request received from the consumer. Resource pooling, we have servers, the physical servers, and those are the resources that we're going to use here. Rapid elasticity appear to be unlimited, and they do appear to be unlimited because none of the machines knows anything about what's going on any of the other machines. And then a measured service, able to measure the usage, report the usage, both transparency and billing purposes, so that we can be billed based on a number of different things. How many minutes we run, how much memory we have, how much CPU, lots of different ways that we can bill. The guy that used to work at Rackspace came in and did a little demo, and I think it was like a penny a minute for a server, kind of a baseline server. So in some cases, that's going to be cheaper for the individuals who don't need to have a full IT staff that they can go cloud computing. You still have to have a good internet connection for that to happen. We're using a form of cloud computing right here. Traffic paths on this thing. Internal clouds are referred to as a private cloud. Private cloud is one that only us are on it. Only us. Private clouds create services within a company only for its internal customers. And again, that's what we did. We had servers that had virtual machines running on them, desktops running on them that users use. We had servers. We did the same thing for students for the Windows courses and the Linux courses. We ran a private cloud so that they had their servers that they could use to do labs with, practice with. They could get on them from inside the campus and from outside the campus in order to do that. Workflow, the use of web applications, send change requests asking for some service or a new VM to the virtualization team. Internal consumers of the IT, such as developers, can select the required service from a catalog. If I had an account at Rackspace, I would be able to go in and do it, go down from a checklist and pick what I want. So send a request asking for some service. Virtual tools will act on the user internal's request and create the required service. So first we request it, and then it's created for us. And when they're started, the services request by the customer will be available. The service will be running on the data center. So now they're up and running. So we need to be able to do that without human interaction, so that we can go to a drop down, have an account. They have our credit card on file. We pick what we want. They create it, send us the information, and we can run it. The internal users so it may have a service catalog internally in order to do that. By adding API application program interfaces, the services catalog will be able to reach consumers' requests such as add, remove, and create VMs. Kind of the same thing that we've been seeing, I think, through this particular slide here. Cloud team, server, virtualization, network, storage engineers, and focus on building a resource pool. So we need the individuals that can accomplish all of these things for us. And then the external and then the internal, we actually did have a catalog where a student could order up his own machine. It was a pre-configured machine. He couldn't pick how much memory or hard drive or how many processors to go, but they could order up a machine for a class. So external, kind of the same thing. Customer asks for some service such as a VM. Virtual tools will act on the customer's request, create the required service. When it's started, the services requested will be available. The services may be running in a data center that will be residing at any location, and this is a big key here. Any location, we don't know where it is. It could be running in Germany. It could be running in Switzerland. It could be running in Poland, I think, has some. So you don't know where your virtual machines are running in most cases. I think some of them will actually let you specify certain countries. Now, the issue that you get into here is that we have different requirements particularly different privacy requirements in different parts of the world. So wherever it's running is where you're responsible for. So the workflow here, customer request, the virtual tools are created and the required services are started based on the request. And we don't know necessarily where they are. The different elements of them, the virtual machine, you've seen them. You've seen me use the server virtual machine software implementation that allows the environment installed and running the operating system typically emulate a physical computing environment. Virtualization layer will manage the request for the CPU. The software is going to manage all of these requests. The hypervisor is the software that allows multiple operating systems to share a single hardware address. So what this is telling us is that we can, this is the software. The hypervisor, VMware Workstation is a hypervisor. It's a hypervisor that runs on top of an operating system. The ESXi, the things that we were talking about, run directly on the metal. They're called bare metal operating systems to do that. And then we have the virtual NIC, support different virtual network interfaces. This is one of the, can become a real bottleneck, because if you have a whole bunch of machines that are trying to use the internet and the virtual NIC gets bound to a physical NIC, at some point you have to have the physical resource in order for these virtual resources to run on it. We share the processor. And if you look at your computer, how much processing do you use on a regular basis? And you look at probably 5%, 4%. Even with all of the stuff that's running on this machine, if it will start it, CPU's at 62%. It'll go down because I just started. So I'm running around 50% with the course running, with browsers running, with the recorder running, with PowerPoint running, 46%. Usually a machine, if you're just doing ordinary work, runs what, around 4 or 5%. So what the hypervisor does is allow us to share the resource, or processor shares the processor, and typically not everybody's going to be doing the same thing at the same time. So it allows the multiple operating system sharing the resources. CPU and memory utilization sharing works pretty well. 89, 90, 95% efficiency. When we're talking about disk utilization, disks run around 60 or 70% utilization. So disk is one of the real bugaboos in this thing. And then the NIC, you've got to have enough processing power in order to have the virtual NIC. So we're going to have the virtual NIC. It's going to be using a physical NIC. Basic services, and we talked about these a little earlier. Software as a service, in which the application services are delivered over the network on a subscription on demand basis. Cisco WebEx, Zoom is an example of these things. Platform, a type of service in which the runtime environments and software development frameworks components are delivered over the network on a pay-as-you-go basis. Typically presented API to consumers. WebEx Connect is as a service. And down here, Force.com, Azure are platform as a service developers here. The infrastructure as a service, rack space that we looked at earlier, which compute, network, and storage are delivered. We can create our own virtual computers, our own virtual machines at these locations. So conceptually, the virtualization. So we're going to access control lists again for traffic filtering. Defined as a sequential list. We talked about that. In ICND1, we had standard list that we did there, and then in ICND2 we do extended list, but it's a what is it? A sequential list, at least one permit statement, because we have the implicit deny. If we have an access control list, allow filtering on inbound and outbound interfaces, and we specify whether it's inbound or outbound where we want to apply the list. At the end of each list, the implicit deny, traffic filters with access control lists help you determine the traffic needs to be blocked and the traffic that needs to be forwarded through the routers. That's what they're there for. Can be configured on a router or layer 3 switch to provide basic network security. So we want to permit or deny. One of the things, and for an extended list, if we have our firewall and we have our DMZ here and maybe a web server here, we want to allow everybody to get to port 80 and 443 so that they can see whatever we're trying to sell or give whatever information we want. If we have a mail server here, maybe 143.25, in order to use the mail services. So we can use an access control list to specify IP address. Remember, the standard is the source IP only, is what it can do. The extended can be source and destination IP, as well as ports, TCP port numbers, or we can do IP addresses with it. So a list of permits and denies, we need to have the more specific things at the top. We can get too general with them and kind of permit too much or deny too much at the top of the list. The system goes down the list one statement at a time. 1 doesn't apply, 2 doesn't apply, 3 applies. It's going to apply that regardless of how many other statements are there. It's going to apply that statement and move on. It won't look any farther down the list. If we don't go down the list until we get to the bottom and to the last statement and nothing has worked, then we get the implicit deny. So that after we've exhausted all the possibilities, checking to see if any of these statements apply to me, any of the restrictions apply, at the end, the default is to deny. So we can filter traffic for both IPv4 and IPv6, provide basic network security, and it is basic network security. The newer firewalls, these new firewalls do deep packet inspections. They look at things. I used to do a DNS spoofing activity until they got a brand new fancy firewall, and it worked great locally, but when it went through the firewall, it did the deep packet inspection, say, oh, you made a mistake, let me fix this for you. So it fixed the DNS stuff. They do an awful lot of good things now. But network access the devices by allowing you to restrict IP related traffic on IP filters that you've configured. We can restrict based on IP address or TCP, UDP, and ICMP port numbers. And ICMP is different from these others. Linux uses UDP for its ping. Microsoft uses ICMP. So you kind of have to know what's going on your network, which protocols that you need to permit and deny on your access control list. Filter container rules attempt to match the IP packet. If the packets match, the rule will also allow you to mention if the packet needs to be permitted or denied. And I like this. Will allow you to mention. You have to give a permit or deny statement on it. Traffic coming into the switch will be compared to the IP or the IPv4 or IP IPv6 access list based on the order that the filters occur in the iOS device. The order that the filters occur in the iOS device. Starting at the top, working its way down, checking to see if any applies. The first one that applies, it doesn't go any further. We can have one ACL per interface, per protocol, and this is not a big deal anymore because the only protocol we're really using is IP. It used to be a bigger deal. Per protocol, per direction. So you can calculate how many we can have. We have an interface here. We can have one per interface, per protocol, per direction. So we can apply it one per interface, IP, one per interface, per protocol, per direction, an IP in and an IP out. I did that wrong. Should be an IP in, and an IP out. Or if we had IPX, we could have IPX also, or AppleTalk, or basically the ones that ever existed. IPX kind of gone away a long time ago. I think the last machine that I ever used it on was a NetWare 3.12, and they're if they're still making them, are in the 6 and 7s now. And then we have the implied deny for all traffic that is not permitted. You must have at least one permit. And I may have told you, and I'm sure I did, but I'll tell again. Network administrator had an individual who was abusing the internet. So, hey, we'll give them a static IP address and deny them access to the internet. Great. Did that, wrote the statement, deny, applied it to the interface, internet goes down. It's, oh yeah, I got to have at least one permit statement. So after we did that deny at the top, deny the one, then we needed to do a permit any if we're doing the extended list. So you have to have at least one permit statement in these things. Otherwise, you're going to deny everything. Standards are the oldest. Control traffic by comparing the source IP packets, the source IP address, source IP. If I could write better, you could probably read this stuff. Source IP of the packets to the address configured on the ACL. The syntax, access list, the number, permit or deny, the host, source, wildcard for 255.0.0.0.255. If you really have trouble with this one, take 255.255.255.255 and subtract the subnet mask. So if we had a Class C network and we subtracted 255.255.255.0, we would have the 0.0.0.255 for the wildcard mask. So what that's really saying is to check the zeros, check to be sure it's, if we use 192, to check to see if it's 168, to check to see if it's 163. And then the hosts, I don't really care. They can be any of them. One of the kind of, for me, dummy checks is that these are always going to be odd numbers. If we had a 4-bit, if we had 192 and we had the mask that gave us 4 host bits, it would be 0.0.0.3. What you can think of if it's a network address, it's 0 plus the next 3. The network address plus the next 3. So what the 1 bit say is, I don't care, don't look at it, they can be anything once we've configured the network. Valid host access list can be any number 1 to 99 and 1300 to 1999. When we did away with the other protocols, it opened up a lot of numbers for the access list. That's an awful lot of access lists if you look at that. There's, what, 98 of them here and then 600 here. going to be one busy device. Can apply it in either inbound or outbound. And you need to specify inbound or outbound. The older routers did have a default, and I think the default was out, so that if you didn't specify it, it would do it for you, but now you need to do it. Interface, and then we configure it, or we invoke it by using the interface IP access group. The number here is the access control list number. And we apply in or out using the IP access group command. If we're using a telnet line, it's a line. No, it's not. It's a different command. So IP access group to apply it to an interface. And it is the number that we're applying. We apply it in or out. Extended access lists give you more information. They'll let you control traffic by comparing the source, destination address. Address is configured with the ACL. Extended filter traffic, protocol, port numbers, precedence values. Valid ACL for the extended are 100 to 199. You notice there's one more here because you can't use 0. 2,000 to 2699. So almost 700 of them there. So it's access list, and we can use a numbered list or a named list. The advantage to the named list is you don't have to type IP access list every time, or access list every time that you do a command. Access list, or it's IP access list, and then the name named, and then we can do that. So we're going to have the name, protocol, the source, and the wildcard, and I've got a couple of resources if you really have trouble with these things, and then the destination wildcard. And we use, again, wildcard mask to specify what goes on with these things. Named access list can be either named by a name or a number. The named list, access list extended, and then the name. The advantage to the named is when we write the commands or write the list, it's going to number them 10, 20, 30, 40. The standard numbered lists, we start at the top, and when we add something, it gets added in at the bottom. In this one, we can add something in. If we decided we need something in here, we could start it out with 15 and then whatever the statement was in it, and it would insert that 15 in here. These, the best way to maintain them is keep them in Notepad. If you need to change something, change it in Notepad, go to the device, wipe out the access control list, and do a copy and paste with your statements from Notepad to prevent having to retype everything. Command will allow you to define the extended list using the name IP access list extended, and then whatever we're going to name it. Another advantage to name it, you can name it based on what it does, so that it's easier to keep track of them. The Cisco Application Policy Infrastructure Controller API, Enterprise API module, and then this is what it does up here. What I've got here, I hope, is a demo, and if you have, and I put in the ccnaldc.blogspot.com a page that's got a link to some Cisco free labs or free learning experiences for some of the high-level things that they have. But this is a pre-configured APIC enterprise model. APIC EM is what they'll call it. What this is here, and this, that not many of the paths are actually working on these things. Okay, so it'll log me out and it'll log me back in. So we'll go to this one so that I have something. What the access control list would allow you to do is we have a source IP here. Let's try 10.1.2.1. Let's try that. 10.1.2.1 because it's good. I've had a lot of trouble here getting things to work. And 10.1.4.2, and we'll go to 10.1.4.2. What you can do here, you can specify the protocol, but you can also do an ACL trace. And what the ACL trace would allow you to do, and say the destination port was 23, we weren't able to telnet to someplace. Start the trace here, and then this has been not doing really lots of things for me, to me. But we got there, we got connected with this one. So if we had a problem with an access control list, it would fail because we would be applying the access control lists to it. And that's why it's in here. We'll talk about software-defined networking a little bit later, but this has discovery, where you can discover your network. Again, this one's pre-configured. It doesn't really have a whole lot in it. We can do CDP. We have to start with an IP address, the seed IP address they call it, so they can start this. And it's CDP 16 protocol, telnet, retry, count 3, timeout, the IP range, and this tells us what's working and what's not working. So branch discovery, CDP, we're discovering addresses. Host inventory, what goes into this thing, and let's say we have a wireless access point here. The topology on this one is pretty disappointing, because you go through all of this stuff and you know there's a bunch of stuff there, but the topology, and again this is set up, you can't change anything in it, goes into this thing, which is this is, if you make this map, back this map out, it's in Italy. So it has 2 network devices in it. Branch 2 router, yourdomain.com. So this is where we are. That's what the topology of this thing looks like. But that's kind of a real quick look at what the APIC EM is. And this obviously shows a whole bunch of other things. But over here, the managed all says that they are unreached. What it allows you to do, this thing allows you to do, is manage your devices. But the specific thing for this particular lecture, controller for enterprise networks, the ACL analysis tool allow you to analyze how flow is affected by ACLs programmed in the path. We go in and tell it what we want to do, that we want it to check the access control list. Analyze both the ingress and the egress interfaces. Tool will show whether the traffic matching your criteria will be permitted or denied, and this one actually doesn't have any ACLs. The following rules will affect them. Only matching access control entries will be reported. Access control entries are the elements of the access control list, the permit and denies. If you omit the protocol source port or destination port, the result will include the entry matches for all possible values of the field. So if you want to check everything, don't put a port in there. If there are no matching access control entries in the access control list, then the flow will be reported as implicitly denied, and then we do have to actually have an access control list before that happens. If there's no matching access control entries, it will be reported as a deny on this thing. So